Good afternoon, everybody. My name is Chee. So today I'll be discussing solutions and strategies for advancing green logistics with a particular focus on energy-efficient warehouse design operations. Warehouses are a crucial part of supply chain, and as we expand, it is essential to reduce their environmental impact. So before we can prescribe solutions and strategies, we need to be familiar with the asset class, and in this case, warehouse. We need to be familiar with the challenges that we will face within this ecosystem. And through this understanding of warehouse and how energy-efficient warehouse can be designed and operated, we can prescribe the right solutions. So today, my scope is to explore and to discuss and introduce various measures that will eventually guide you in terms of how you're going to design and operate an energy-efficient warehouse. So let's start by looking at the distribution of energy in warehouses. And definitely, there are two different spectrums of warehouse, from non-refrigerated warehouse to refrigerated warehouse. And the energy cost as a percentage of the operational cost ranges from 15 to 60%. And if you dive deeper into the operational cost, you'll find that within the energy cost, the biggest component in terms of where we consume energy is primarily the heating, ventilation, and air conditioning within the warehouse. So this enables us to zero in on where is the biggest impact. Where should we focus our design consideration? Where should we focus our operational attention and resource? Okay. So diving deeper into the main strategies and the solutions that we face on a daily basis. There are so many solutions in the market. And right now, I have crystallized them into four main categories, whereby design is still the most impactful phase in how we arrive at the energy-efficient warehouse. So design is not only for new warehouses, but throughout the whole life cycle of a warehouse, we encounter several key milestones whereby we make CapEx decisions over the next 10, 15, and 25 years that will transform the energy utilization of the warehouse over the next 10 to 15 years. So design is not only right for new construction, but throughout the whole life cycle whereby at critical milestones, we make decisions that affect the energy consumption over the next 10 to 15 years. And in this case, when I crystallize into four main categories, passive design is primarily something that is high capex, but when chosen correctly, it does affect or impact positively the energy consumption over a long period of time. So take, for example, if you have good building insulation, it prevents the cold air from leaking out. It also prevents the solar heat from radiating into the building. So in this case, there could be a heat resistance paint or a heat resistance coating for the glass, whereby you only allow visible light to come in and not the UV and the infrared. So these are passive design that once you install, it lasts over 10, 15 years. And the selection of energy efficient equipment is also very important, whereby you may be able to buy all the most efficient equipment together, but if it doesn't integrate well, it is not the most energy efficient system. So take, for example, you can get a very efficient pump, but the pump has no intelligence. The pump can't calibrate itself whether should it run at a faster speed or lower speed. So it takes a building management system, it takes smart IoT to be able to collect the data and analyze them through the cloud, and from there, instruct an energy-efficient pump to increase or decrease its speed. So this is how we are able to bring in smart controls integrated with energy efficient equipment before to achieve an optimized system. And I've intentionally put renewables as the last segment. Primarily, when we design buildings, we always look into the optimization of a passive, active, and smart controls by bringing down the most efficient energy utilization benchmark. And once you have the lowest possible energy utilization footprint, then you prescribe your solar and renewable energy in order to achieve what we call in Singapore a net zero energy building. So if you have heard of Newton Green by DBS, we are the project manager for bringing a 35-year-old office building into a net zero building within the second month of operations. And that's through the principle of reducing the energy consumption to the most optimal before we integrate these solar panels. So the challenges are inevitably money in terms of the investment to solarize is generally high capex. There's ROI concerns, and you need to be able to relook into the payback period in the sense that when you are able to design very carefully, the payback periods can be shortened when you are able to mix and match various initiatives together. And one of the challenges that we face when we work with our warehouse owners is that the tenant tenure is sometimes a barrier to the implementation of energy savings because the payback and the tenanted lease period sometimes are almost equivalent. So when it comes to that, it's hard to engage the tenants to get a buy-in to support your energy efficient initiatives, and whereby you may have to consider some incentives in order to bring them on board of the journey. And for existing warehouses, the challenge is always there are some site constraint, there are prerequisites that is hard to change, and it's also difficult to solarize the roof because of the nature of the previous design. So these are sometimes some structural challenges that would need to be reviewed more carefully. Of course, the same problems would also brings about, will actually enable them to be part of the solutions as well. So earlier I talked about the tenant engagement in the sense that you may have the best crafted plan. If there's no tenant support, there's no engagement, it's hard for the plan to be successful. So today we rely on a lot of green lease arrangements with incentives whereby if the tenants perform, the tenants meet the target, they could actually get some carbon credits or carbon or some renewable energy sold to them at a very preferential rate. And through the integration of the right mix of passive, active, smart controls, and renewable energy, you're generally able to put together a plan that is able to meet your payback period requirements, as well as to be able to work with the banks for sustainability loan. So this is one of the factors that we have identified when we work with DBS in 2021 in terms of their DBS Green net zero energy building. And generally, we believe that green logistics is a strategic priority in terms of how energy efficient can improve on your net operating income. And by being energy efficient, it means that you have a low operating cost. And generally, we say money talks. But how does money talks? Money talks to you in terms of profits. So the first way is that when you have lower operating costs, it gives you good margin, it gives you good profits. And from the good profits, it leads to the second way whereby you get better leverage from the bank. And this is where you get preferential loan rates, you get more leeway from the bank to invest in other business. And in turn, when your portfolio or warehouse performance goes up, you get equity investment. So that's the third way that money can talk to you. And I've mentioned best crafted plan, useless if, let's say, there's no tenant engagement. It needs to be a very collaborative approach with incentives, with some stick in order to engage the tenants to perform. And in terms of future-proofing assets, I've mentioned that for every dollar saved, based on the real estate approach, if you have a cap rate of, let's say, 5%, every dollar that you save translates to $20 more when you sell the building. So take, for example, if you have a low operating cost by 100,000, at the cap rate of 5%, your building is actually worth $2 million, more than that, more when you sell the building. So this is the importance of how, if we can ensure that we have very good energy utilization, very efficient, it brings about a low operating cost. And as responsible organization, we are all corporate citizens of the world. Not only do we want to be the best in our business, we want to be the best in the business for a better world. So this is where I think as we are committed to sustainability, we are committed to continuous improvement, we are generally working this target towards being best in our business for a better world. And how can we help? So Cushman & Wakefield is not only a real estate company, we are also an energy services company whereby we help clients to save energy, save water, and minimize waste. And this is what we are committed to in terms of how we help our clients. And this is primarily what I have for you today. And if you have any questions, yeah, I'll be happy to answer after the next speaker. Thanks.
Hi, good afternoon, everyone. I'm Francis, and thank you for having me here today. Together, let us now discuss something that often overlooked but crucial to a greener and more sustainable global supply chain, which is responsible refrigeration. And here is what we'll be covering today. And as the world gets warmer, right, more people rely on AC, right, like what you have seen, you can see on top, and refrigeration for comfort cooling. So the question now is, can we fight global warming with refrigeration? Or will this make the whole problem worse? Now let us look at what is being used in the refrigeration system. The liquid in the system that used to transfer heat, and particularly the hydrofluorocarbon or HFC refrigerants, are very powerful global greenhouse gases. They can stay in the atmosphere for decades, trapping heat and accelerating global warming. So this creates a paradox now, because with increased refrigeration use, it leads to even warmer and hotter temperatures. So in other words, if we do not take action, we risk being caught in a vicious cycle. Refrigeration systems are critical, not just in building, but also on ships, right? Providing comfort, maintaining the goods and food. And there are two ways how they can contribute significantly to the emissions. First of all, as you have seen just now, refrigeration system is one of the biggest user of electricity, which can lead to higher fuel consumption. Secondly, HFC refrigerants can leak directly into the atmosphere from the system. According to the studies by UNEP, EC, and Nordic Council of Ministers, ships lose 20 to 40% of their refrigerants annually through leaks. And this rate is much higher compared to office and residential buildings because the ships are exposed to continuous motion on the ocean, which can cause damage to their refrigeration piping. And the IMO fourth greenhouse gas study estimates that the refrigerant losses from ships in 2018 equal to 18.2 million tons of CO2 equivalent. And the biggest contributor to such high emissions is HFC like R448. It is a very popular refrigerant with high global warming potential. And with a leak rate of 20 to 40%, right, a ship can easily consume one or more such cylinders per year. And the impact of one such cylinder equals to the emissions from 38 cars driven for a year. This is why there are global regulations such as the Kigali Amendment to the Montreal Protocol and the EU F-gas regulation phasing down the HFC. And the Kigali Amendment to the Montreal Protocol was signed by 197 UN countries in 2016. The countries are being divided into two main groups. For the first group, the A5 countries like China, Panama, Brazil, and Singapore, we have just started the phase down this year by introducing a quota system which will limit the amount of HFCs that we can import and produce within the country. For the second group, the non-A5 countries like Canada, Australia, and Japan, they have started the phase down earlier in 2019. And in the US, the prices of HFC refrigerants tripled overnight when they started the phase down in 2022. And this year, the amount of HFCs available in the countries has been reduced further from 90% to 60%. The EU is much ahead than the rest of the world. As you can see, they have started the phase down almost 10 years ago. And just earlier this year, in March, the new F-gas regulation came into force with a stricter requirement and an accelerated phase down. And because of that, this has driven up the prices of refrigerants in the EU further. So with the global HFC phase down, what are the challenges we might face? Based on the recent development in the EU and US, we are likely to witness a significant rise in refrigerant prices after 2024. And this time, it will not impact just US and EU, but also other parts of the world. Secondly, the availability of HFC will be severely limited, right, making it troublesome for the building owners, for ship owners to maintain their system. And lastly, with the quota system and the high prices, this may create opportunities for the sales of illegal or counterfeit refrigerants. As per the report by Cooling Post, there have been a steady rise in the HFC smuggling activities in recent years. And these refrigerants are dangerous because they may not have the necessary quality. They may even contain banned substances. In 2011, 3 reefer containers exploded while stacked at the container terminal, killing 3 workers. Investigations revealed that counterfeit refrigerants were used. And this highlights the danger of such refrigerants. Besides the HFC phase down, there are regulations like the US EPA, the IMO, as well as the European standard also have measures to minimize refrigerant loss. And that includes prohibition on venting, record keeping, and leak detection. Compliance is critical for us to achieve our net zero emission, and it is also help to safeguard the health and safety of the crew and passengers, as well as avoiding the higher operating costs and fines. These 2 reports highlights the cost of non-compliance. In 2019, a fishery giant was caught violating the US EPA rules, resulting in a huge fine of 24 million USD. And in 2021, a company in the UK was received a fine of £1 million for F-gas violation. So how can we overcome all these challenges? We recommend adopting the responsible refrigeration approach. The step 1 is to adopt low GWP refrigerants. And to assist you in selecting the right refrigerant, we have developed a web-based calculator which is available for free.
With the next major HFC refrigerant phase down in 2024 set by the EU F-gas regulations and the Kigali Amendment, it has never been more important to consider using refrigerants with low global warming potential. To help you visualize the impact and recommend the suitable options available, we've got the perfect tool for you. Here's how you can get started. First, decide if you are calculating for an existing ship or a new build vessel. For existing ships, choose your currently used refrigerant. Key in the amount of refrigerant purchased or topped up with the correct time period. Finally, select the retrofit refrigerant you intend to use. Click here to see the difference that a low GWP refrigerant makes. Our calculator will show you how much CO2 can be reduced annually. You can see just how much CO2 emissions you save with our CO2 equivalency diagram. It even shows you other suitable options available. Try the refrigerant calculator and speak to us to learn.
Thank you. And the step 2 of our responsible refrigeration approach is to minimize refrigerant loss. That means refrigerants has to be recovered safely before any retrofitting or repair works is performed. And furthermore, leak prevention and detection must be carried out to ensure the system integrity. For example, an electronic handheld leak detector can be utilized to perform day-to-day check, and a fixed leak monitoring system can be installed to provide round-the-clock detection. The final step, step 3, is to reduce indirect emission. As my previous speaker mentioned, we can do that by optimizing the system, right? By utilizing all this, implementing the strategy that Mr. Ho, you have just mentioned, we can reduce the cooling load, we can improve the overall efficiency. And lastly, it is also very important for us to avoid the risk of getting illegal or counterfeit refrigerants. So we have to be mindful and only obtain the refrigerants from reliable and reputable sources. So to summarize, we have discussed about the danger of HFC refrigerants, right? The regulatory requirements as well as the associated challenges. By adopting responsible refrigeration, we will be able to break the vicious cycle and move closer to our net zero emission goal. Thank you. Thank you for your time.